Hello everyone, this is Team 2. Our topic is engineered barriers of dry disposal of radioactive waste. There are three parts. The first part is engineered barrier systems. An engineered barrier system can be defined as the man-made, engineered materials placed within a land environment, including the waste, covering materials, lining materials, drainage, the leachate collection, and monitoring systems, the leachate detection. Radioactive waste disposal systems typically include a system of barriers that acts to isolate and contain the waste and thereby protect the environment and human health. The presence of several barriers with complementary safety functions is designed to enhance confidence in the protection that will be provided. The barriers include the natural geological barrier and engineered barrier systems. The EBS may itself comprise a variety of subsystems and components, such as the waste form, container, buffer, backfill, and tuner seals and plugs.
The second part is engineered barriers approaches. Depending on the composition, waste can be conditioned by turning them into solid blocks or binding them together with cement or resin to reduce solubility. This forms the first barrier. The second barrier is formed by the containers into which the waste is placed either with thick copper or steel walls or concrete or steel boxes. The containers filled with this conditioned waste will be taken hundreds of meters underground into the GDF. In the GDF, the containers are surrounded by buffer materials that protect them, reduce the passage of water to the containers, and minimize the passage of any radioactivity from the containers. These materials form the third barrier. The fourth barrier, of course, is hundreds of meters of rocks that separate the containers from the surface environment. So between people at the surface and the waster, a set of carefully engineered barriers, a suitable container, for example, made of copper, steel, or concrete, a backfill betonite or cement, and a lot of rock, will protect the environment and keep everybody safe until the radioactivity has decayed and the waste can no longer cause harm. Effectiveness of these barriers depends on finding a site where the host rocks and the rocks overlying the GDF have the right characteristics.
Okay, the final part is the engineered barrier functions. This figure shows the barrier components and the functions in many aspects. The first is the waste form is to solidify the radioactive waste and prevent scattering, dispersion, spraying, and leaching for the radioactive substance from the waste form. The second is the waste container to isolate waste from the environment and to resist degradation, and to protect against mechanical damage and contain with water. The third is the backfills to limit the water infiltration, sorption, and precipitation of radionuclides and gas mediation, and also limit the release of the radionuclides to the far field in the event of contained feature. The fourth is the structural material and liners to ensure the physical stability to protect the waste and contain the waste. The drains is to manage the water and the leachate collection. For the caps is to cover the surface layers to prevent the infiltrations, to prevent corrosions and the leaching of the radioactive substance. So here's a reference, and thank you for listening. And do you have any questions?